This lesson is a review of midpoint and distance formulas. So our objective is to find the midpoint of a segment and to find the distance between two coordinate points. We're going to use this as a review, like I said, of what you should have already been learned in previous math courses about midpoint and distance, but it's going to be used here to see how it relates to the Pythagorean theorem, which will be our next lesson. So if you look at the midpoint formula on a number line, the coordinate of the midpoint is the average or the mean, which is just another word for average, of the coordinates of the endpoints. So here on this particular line segment, we have point A with coordinate lowercase a and point B with a coordinate of lowercase b. To find the midpoint, you would add those two coordinates together and divide by 2 to find the average of those two. Now in the coordinate plane, the coordinates of the midpoint are going to be the average of the x coordinates and the average of the y coordinates. Of the endpoints of the segment. So if we look here in the coordinate plane, we're really looking at two line segments. The x-axis is one line segment, and the y-axis is another line segment. The point A, the coordinates are x sub 1 comma y sub 1. Point B, your coordinates are x sub 2 comma y sub 2. And the midpoint of segment AB is going to be a coordinate point, and the x coordinate is where you add your two x values together, x sub 1 plus x sub 2, and divide by 2. So you're finding the average of the x coordinates, and your y coordinate of the midpoint. You add y sub 1 plus y sub 2, divide that by 2. So that is the midpoint of the segment in the coordinate plane. So let's go down and look at how this applies to the distance formula and how the distance formula is going to apply to and relate to the Pythagorean theorem. The distance formula is actually based on the Pythagorean theorem. Because when you use the distance formula, you're really finding the length of the side of a right triangle. So look at the diagram and see how this relates, the distance formula, to the Pythagorean theorem. Here we're trying to find the distance or the length of the segment AB. So let's look at the bottom side of this right triangle. The horizontal length of that leg is the difference between the x values, x sub 2 minus x sub 1. We'll call that side A of the right triangle. And then if we look at the right side of the right triangle, the vertical side, that's the difference between the y coordinates. We'll call that side B of the right triangle. And then the distance we're trying to find, we'll call that C, which is actually the hypotenuse of that right triangle. So if we look at this in terms of the Pythagorean theorem says that c squared is equal to a squared plus b squared. Here in this diagram, our c is actually d, which is the distance we're trying to find. And then the a is the difference between our x coordinates, x sub 2 minus x sub 1, parentheses squared, plus our b in the diagram is the difference between our y coordinates, So that's y sub 2 minus y sub 1, parentheses squared. If you take the square root of both sides to solve for d, instead of a d squared, we want it to just be d to solve for d. So if you take the square root of both sides, you can have d is equal to the square root of difference between your x coordinates squared plus difference between your y coordinates squared. And that is actually the distance formula. So that is how the distance formula is derived from the Pythagorean theorem. Let's look at some problems for midpoint and distance. In problem 1, we're finding a midpoint. Segment FG has endpoints at -3 and 7. So this is just a number line. And so we're going to find the midpoint of segment FG by taking the average of the endpoints. So we're going to add those two endpoints together, which is -3 plus 7, and divide that by 2. So that's going to be 4 over 2, which is 2. So point 2 is going to be the midpoint. The midpoint in problem 2, finding the endpoint, here it gives you the midpoint, and it gives you one of the endpoints, and you're supposed to find the other endpoint. So to do this, they gave us one of the endpoints, which is point L. L is -3, -5. And then it gave you the midpoint. The midpoint is A, which is 2, -1. So you've got to find the other end of the segment, LM. So you've got to find point M, which is somewhere out here, and it's going to be x sub 2, y sub 2 is what you're trying to find. So to do this, you need to apply the midpoint formula. So the midpoint formula for LM is going to be the difference between your x coordinates, which the x coordinate for L is -3, and you're going to add your two x coordinates together. We don't know the other x coordinate, and divide that by 2. And then you do the same thing with your y coordinate. You're going to add your y coordinates together, which the y coordinate for L is -5, plus your y coordinate for M, which we don't know, y sub 2, and we're going to divide that by 2. Now the midpoint of this segment is point A. So to set this up, we're going to have point A, which is actually 2, -1, is equal to what we just set up here. It's equal to these two coordinates that we have set up. So we have to separate these. The x coordinate of your midpoint is 2. So the x coordinate of A is 2. So we need to set 2 equal to the x coordinate of your midpoint that you set up, which is a -3 plus x sub 2 divided by 2. And to solve for this, you're going to have to multiply both sides by 2 to get rid of the fraction. Times 2 times 2. Get rid of your 2 over there. So 4 on the right side. It's -3 plus x sub 2. And then you're going to add the 3 to both sides to solve for x sub 2. and x sub 2 is 7. So your x coordinate of your endpoint that you want is 7. So now you have to do the same thing with your y coordinate. Only your y coordinate, you're going to have -1 as your y coordinate of your midpoint. Let me change colors. So we have -1 is equal to your y coordinate of your midpoint, which is -5 plus y sub 2 divided by 2. Once again, we're going to multiply both sides by 2 to get rid of the fraction on the right side. And you're going to have -2 is equal to -5 plus y sub 2. You're going to add the 5 to both sides to solve for y sub 2 is equal to 3. So the coordinate or value that you're looking for the other endpoint m is going to be 7, 3 is your answer. Problem 3, you're just finding the distance between two coordinate points. So let's apply the distance formula. Distance formula is distance is the square root of the difference between your x values squared. So your x values here are -5 and a 6. So -5 minus 6 in parentheses squared plus the difference between your y value squared, which is a 3, minus a -2, which is 3 plus 2, parentheses squared, equals square root of -11 squared plus 5 squared. And don't forget that when you square a negative, you're going to get a positive number. That's where a lot of people miss this type problem. A -11 times a -11 is a positive 121, and then a 5 squared is 25. So you're always going to get a positive number underneath your square root sign, because you can't take the square root of a negative number in the real number system. So you're always going to end up with a positive number, which here's the square root of 146. And if you take the square root of that, this is going to be approximately 12.1 units. In problem 4, again finding distance. This is a zipline course. You're harnessed to a cable that travels through the treetops. You start at platform A and zip to each of the other platforms. How far do you travel from platform B to platform C? Well, the coordinates for B, be careful of your scale. Your scale on the graph is going by tens. So B is a -40, -30, and C is 30, 10. So we want the distance traveled from B to C, so we want the length of segment BC. So that's going to be the square root of -40 minus 30, difference between your x values, -40 minus 30, parentheses squared, plus difference between your y coordinates is 30 plus 10, parentheses squared. So that's going to be the square root of a -70 squared plus 40 squared, which is the square root of 4900 plus 1600, which is the square root of 6500, which is approximately 80.6.